Suppose you're observing a business whose total cost to produce 100 items is $1,114, and the total cost to produce 500 items is $5,034. Find the linear cost function to model the data. So, let's see. We know that the total cost to produce this much is there. We know the total cost to produce that many items is here. So if you kind of think about it, the number of items in general are x's, and the costs are our y's. The number of items are the x's, the cost is the y's. So essentially we actually, if you think about it, we actually have, oops, that should be y1. We have 2 points here. We have x1, y1, and x2, y2. This is, just like if we had a graph and we were trying to find the equation of a line, and when we had 2 points, we're doing the same sort of example, or same sort of idea here. We have 2 points, we're trying to find the equation. And if you think about where we would start there, well, the only thing we can really start with, I might have hinted at it by just calling this x1, y1, x2, y2. The only time where we've really done that is when we're using the slope formula. So that's what I'm going to do. I'm going to say y2 minus y1 over x2 minus x1. Alright, so that is, I'm going to call this my second point, and this one my first point, just like I labeled them there. 5034 minus 1114 over 500 minus 100. And pull down the calculator. We have 3920 over 400, which gives us 9.8. So the slope here, maybe I shouldn't have drawn it like that. Really what we have is we have the cost to produce 50 items is there, the cost to produce 100 items is there, the cost to produce 500 items is, let's say, here. We're trying to find the equation of the line that looks something like this. So we found the slope so far. Now we have a slope, we have 2 points. We only need one of those points. I'm going to choose the first one, this 1114, because the numbers are smaller, really. And I'm going to say y equals mx plus b. Let's see, we get 1114 equals 9.8 times 100 plus b. I'm just plugging in what I know there. 9.8 times 100. Oops. There. Is 980. Subtract 980 from both sides, we get 134. So we have our y-intercept, we have our slope, we can get the equation of the line. Instead of saying y equals mx plus b, I'm going to go ahead and say c of x equals 9.8x plus 134. Looking at this as a little added question, you can actually observe that the fixed cost is $134, and the marginal cost is $9.8, so $9.80. It costs $9.80 to make one additional item. It cost $134 initially to set the whole process up. But like I said, that was a little additional thing. The actual answer to the question was the cost function, because that's what was being asked for, right? Find a linear cost function to model the data. Yep, that's what I got there. Alright, what is the predicted cost to produce 600 items? Well, we're just saying here this is x. So 9.8 times 600 plus 134. This is my cost function. Specifically, that's the cost of 600 items. Which gives me, I'll just pull down my calculator. Oops. 9.8 times 600 plus 134 gives me 6,014. If items are sold for $20 each, how much would need to be sold in order to earn a profit of $2,000? Alright, so there's a couple of things here. R of x, what was the variable used for that? I think it was A. Whatever price we're selling each item for, we're going to call that some number. I'm calling it A in this case. Our profit is, in general, your revenue minus your cost. So we know a little bit here. We know that the total profit is going to be $2,000. We know our revenue. Well, this is going to be A times not 2,000. How many? Oh, oops. What am I doing? All items are sold for $20 each. That's that number right there. It's this number that I was trying to find, the x. So 20x. Then we have minus our cost function. And cost function, which is up here, 9.8x plus 134. Now, I don't know the value of x. You'll notice I'm leaving that as just x in both of these. I did know that my total profit was $2,000, so I didn't need to really write that as anything, any sort of function related to x, because I know its value. So I'm just saying my profit is $2,000. My revenue for making a certain number of items is just R of x, or 20x. My cost for making a certain number of items, well, that's just my cost function. I already wrote it there. And let's just clean this up. 2,000 equals 20x minus 9.8x minus 134. All I'm doing here is distributing my negative through the parentheses and dropping those parentheses. Let's see, this gives me 2,000 equals 10.2x minus 134. Just combining those two terms. I'll add 134 to both sides to get rid of this. We end up getting 2134 equals 10.2x. Divide both sides by 10.2. You can see there is a lot of value once you set up an equation. It's just a matter of, using some algebra to solve this thing. And we have 2134 divided by 10.2, which gives us 209.21. Whatever. I'm going to go ahead and call this 209 items. An argument could be made to say that you'd want this to be 210 items, always rounding up to make sure your profit is at least $2,000. I'm comfortable with it being close enough to $2,000 there. If you wanted to check to verify, so this would be your answer. It's never a bad idea to check your work to make sure everything works out. We did some weird steps here. Let's just compute it. Let's figure out what our total revenue for producing 209 items is. This is $20 each times 209, which is $41.80. And your total cost for producing 209 items is 9.8 times 209 plus 134. Which gives us, oops, I lost my calculator. 2182.2. And for your profit of 209 items is going to be revenue minus your cost. And when I do that, 4180 minus 2182.2. You can see we earn, our total profit here is 1997.8. So you can see when we produce and sell 209 of these items, we earn just under $2,000. That's what our profit was. If we were actually looking for the profit to be at least $2,000, that's where I was saying we would want to round this up to 210 items. We'd want to sell one additional item. So, in any case, that's that one.